Very nice conceptual question. Given to you is the set which consists of elements which look like this. Focus A and B are integers. So integer plus another integer root 2 times root 2. That's how your elements are looking like. Look at another two sets. T1. T1 is negative 1 plus root 2 power n. N is a natural number. Now, can you think of like if you plug in any n to be any natural number, okay, if you expand it, do you think that you will always land up into an element which is element here? See for yourself. Similarly, T2, okay, it is 1 plus root 2 power n. Again, n is a natural number. You raise any natural number, can you see any element here will again end up to be an element in the set S. Okay, anyways, let's try answering the questions. Which of the following statements are true? Number A, Z integer set union T1 union T2. That is a subset of S. Just now we discussed, right? That T1 and T2 will be a subset of S. Okay, so the union will also be a subset of S. But if you union it with Z, then is it still a subset? Yes, right? Because you're saying A and B are integers. So B can be 0 also. In case B is 0, all the integers are there in the set S. Okay, so this is perfectly true that Z union T1 union T2 is a subset of S. Comment me if you don't understand this part, okay? I will try answering you. Okay, let's look at the B1. T1 intersection, this interval is phi. Okay, now let's focus just on T1. What is T1? See, minus 1 plus root 2 power n. Okay, n is a natural number. Now, what is this inside number you see? What is value of root 2? 1.414, something like that. Okay, when you subtract a 1, you get zero point 0.4 something. Okay, now if you have any small number, okay, lesser than 1, and then you keep on raising the power to that, don't you think the number becomes smaller and smaller and smaller? Yes. Okay, if the number is becoming smaller and smaller and smaller, do you think that if you keep on raising your n in the neighborhood of 0, there will be infinitely many elements of the set, right? Okay, but what are they saying? They are giving a neighborhood of 0 and which they are saying that there is no intersection of T1. It's phi, which is completely untrue, right? This is not true because there will be infinitely many elements in the neighborhood of 0. Let's try answering the C part. T2, okay, we have to focus on T2. Let's see what is T2. 1 plus root 2, okay, so 1 plus 1.414 around approximately, okay, power n. So you are getting something which is greater than 1, okay, 2.414 power n. What is happening? If you keep on increasing, because n is any natural number, right? If you keep on increasing your n, can you see that this is going to be huge number, very, very large number. T2 intersection this cannot be equal to phi, right? Because there will be so many numbers which will be here. Because it our wish we can take n to be as big as possible. Okay, so this is absolutely true that its intersection cannot be phi. Okay, there are so many elements in T2 which will lie here. Okay, just concept wise you have to check. Okay, you don't have to give any number or anything here. Okay, let's focus on D1. For any AB in integer set, okay, this is integer if and only if b is 0. Okay, so for instance, let's assume that it is an integer. Okay, this whole thing is an integer. What does that mean? Of course, that means imaginary part is 0 if it's an integer. Okay, sign of anything, when is it 0? When its argument is integer multiple of pi. Okay, so that means you're saying that this thing should be an integer multiple of pi, right? Yeah, so what does that mean? Pi cancels out. That means this is an integer. Right? When can this be integer? When your b is 0. Okay, so this is true. Okay, this is an integer only when your b is 0. Otherwise, like if b is 0, then if b is 0, then what's going to happen? You have cos pi a plus I sine a pi. Okay, what is this? Sine a pi is always 0 because a is an integer. Integer multiple of pi is always 0. So you end up in getting cos a pi, which is of course an integer, right? Because if a is an odd number, it's -1. If a is an even number, it's +1, right? Okay, so this is also true. Okay, so other than I think b, everyone else is true. Okay, very nice question. See you with another one soon.